Today we will discuss some important definition first before the start of this topic. How to represent any differential equation in term of this state space representation. So first of all, what is a state variable? State variable, it is just defined as state variable. It is defined as smallest set of the variable, which determine the state of dynamic system. Smallest set of variable which determine the state of system. Then after that, second is that what is state? What is state? If you want to define state, then the state of a system is the smallest set of state variable such that knowledge of these variable in addition to initial condition. In addition to initial condition, just use to calculate response of the system at any time t greater than t naught. Then after that, state vector So if you want to define state vector, it is the n state variable, or if n state variable are necessary to determine the behavior of a given system, the variable can be considered as the n component of a state vector, right? And then after that, this last definition is state space. So n dimension across which these vectors are just represent that space of the n dimension, that is known as state space. So these four definitions are just related to each other. We will just correlate them and find how that are helpful for us in case of this state variable. So first thing is state variable. It is the smallest set of variable which determine the state of the system, right? So we may have some variable like temperature, pressure, or this may be any physical quantity or any non-physical, any electrical quantity, right? So this, if we are having that smallest set of the variable which may be used to calculate this state of the system, then it is known as state variable. Then what is state? If we are having that upper one means some smaller set of the variable, and in addition to that, we are having initial condition. That means what are the values at t is equal to t naught. Then knowledge, if with the help of that two, one is the smaller set of variable and another is initial condition, we will be capable to calculate the state of the system at t greater than t naught. Then that will be known as state. Then state vector means we are saying that we are having n number of the state variable. We are having n number of the state variable, and that will be just distinguished in the n dimension. So that n dimension are known as state vector. And last one is state space, that n vector are having the different direction. So that space which will cover by that n vector, that are known as state space, right? So these four definitions are helpful for you people to for the understanding of this state space representation. State space representation. Now, if let us say we are having one differential equation. Let us take an example.
Sir.
Just a minute. Yes. Now, we want to represent any of the differential equation in term of state space. So state space means I just want to represent differential equation in term of matrices. In term of matrices, right? Because it is already we have discussed, it is somewhat difficult to solve some differential equation, and instead of that, if we are having that nth order matrix or n by n matrix, then solution of that matrix or that will be comparatively easy. So that's why we want to convert that nth order differential equation into in term of matrix, right? So let us take an example. Let us say this is d2x upon dnx upon dt square plus dn minus dtn upon dn minus 1 x upon dt n minus 1 plus so on. Last two or three terms may be d2x upon dt square plus dx by dt plus x, right? So this may be having this is your differential equation, and this may be having some constant like a1, a2, a3. Here I'm taking a1, and in this I'm taking a2. Here it will be a3. That means this may be 1, 2, 3, or any of the fractional number, right? So here in this case, this may be a nth order differential equation. This may be nth order differential equation, which is used so here it will be the nth order differential equation, right? Now output of this system that will be represented by y, y naught, y1, y3, like that, right? Now We know that I'm just taking the x1 is equal to x. Let x1 is equal to x. Now this x, which is having no differential term, that will be considered as x1. Then after that, x1 dot is equal to x2. x1 dot is equal to x2. Now what is x1 dot? This will be dx by dt. Dot means differentiation of that. Then after that, x2 dot is equal to x3. Now what is x2 dot? Means this will be d. x2 dot means d by dt of x1 dot. And what is x1 dot? D by dt of xt. So this will be d2x upon dt square. d2x upon dt square is equal to x3. Right? And this process will be continue. Right? I may take this as a xn minus last term will be xn minus 1 dot, that will be equal to xn, right? And last term, that is xn dot, this will be represented from this given equation. Always last term will be calculated from the given equation. So if you will be able to calculate it, right? If you will be able to calculate it, then this will be like all the terms will be moved on the other side. So this equation, this will be equal to some ut, right? So xn dot, that means this term, this will be equal to ut minus all the terms will be moving on the other side. X is equal to x1 minus, then this second term a3 into x2 minus a2 into x3, okay, d2x upon dt square, d2x upon dt square, that will be equal to x3, and so on. This will be your a1 so on minus a1 xn, right? So this equation, this last equation, this will be calculated from the given figure. So if you calculate it, just determine it, then if order of the differential equation is n, if order of the differential equation is n, then number of your these variable, that will be again n, right? So this will be dependent upon number of, if that order of the differential equation is n, then we are having n number of the x1 dot, x2 dot, x3 dot, so on up to xn dot, right? So this will be, in addition to that, here it will be ut. So this equation, these equation, let us say x1 dot equation, that will be considered as equation 1, equation 2, so on up to equation n. So these equation will be represented in term of matrices, right? So here this will be in state variable form, in state variable form, this will be x1 dot, x2 dot, x3 dot, x4 dot, so on up to xn dot. This will be equal to if you see, this will be some matrix into so in state variable form, x1 dot, x2 dot, x3 dot, so on up to xn dot. This is equal to into x1, x2, x3, so on up to xn. Right. So here it will be, if you see, first element is 1, rest all are 0 up to n. Then second row, first is 0, then after that 0, 0, 1, so on. And the last row of the matrix that will be calculated from this x1, this will be minus 1 because with it I am not taking any coefficient. Then with x2, this will be a3 minus a3. Then with minus a2, so on. Last may be a1. Right. So this plus one term that will be remaining, that will be u of t. So this will be taken as, because this is only present in the last state variable form. So this will be 0, 0, 0, so on up to 1 into u of t. So if you represent it, if you see it, this will be x dot is equal to ax plus bu. X dot, that will be equal to ax plus bu, where x dot is equal to ax plus bu, where a is a matrix, x dot is equal to ax plus bu, where a is a matrix of the order n by n, b is a matrix of the order n by 1, x is the state vector of the order n by 1, and u is a control, that means it is an input and it is a scalar quantity. So this equation, this is a standard equation. All of your either we will represent any mechanical system, either we will represent any electrical system, either we will represent any differential equation. In case of state variable, always the final state equation will be into the form of x dot is equal to ax plus bu. Will be into the form of x dot is equal to ax plus bu, where x represent state vector, u represent control, A represent matrix of the order n by n, and B represent matrix of the order n by 1, right? So by this way, you may represent any equation in term of this state space representation, and x dot is equal to ax plus bu. This is the state equation, and output equation that will be into the form of y is equal to cx. Actually, this will be cx plus du, but in number of time this d will be null matrix. Number of time this d will be null matrix. So that's why we will only take y is equal to cx, right? Output will be given as y is equal to cx plus du, and x dot is equal to ax plus bu. So by this way, you may represent any this nth order differential equation into the form of yes, please. So if you found here, in this case, I am taking x1 dot is equal to x2, x2 dot is equal to x3, and so on. So x1 dot, what is the meaning of x1 dot? This will be dx by dt, right? Then x2 dot d2x upon dt square, x3 dot d3x upon dt cube, and so on, right? So what does this mean? Number of state equations are equal to number of differentiation, right? Number of state equations are equal to number of differentiation. So if we are having any electrical network, if we are having any of the electrical network, then in that particular case, it will be differential equation is equal to this number of capacitor and number of inductor present in the network. Number of inductor and number of capacitor present in the network. In case of electrical network, number of differential equation is equal to number of inductor and number of capacitor present in this network, right? So if we want to represent electrical network equation, we want to represent electrical network equation in term of state space representation, in term of state space representation, number of that state variable are equal to number of state variable are equal to number of the inductor and number of capacitor represent in the network, right? Let us suppose if in any network we are having 2 inductor and 3 capacitor, then number of the state variables are equal to 2 plus 3, 5, right? Then we are not interested in that how much farad of the capacitor is there, right? Then in that case, we are not interested in that type of the figure. We are only interested in that how many number of the that state variable are there, that will be equal to number of this inductor and number of capacitor in the network. So this is the end of the lecture. Right? We will meet in next lecture again. Thank you.